Today we are going to discuss about the velocity of center of mass. Consider a system which contains in masses m1, m2, mn whose position vector are r1, r2, r3 and rn. Center of mass is at this position. This is the center of mass whose position vector is rcm. Total mass is concentrated and velocity of center of mass is vcm. So see here, but we know that center of mass rcm, center of mass position vector is equal to क्या m1 r1 m2 r2 like that mn rn divided by total mass m1 plus m2 plus mn. Here sum of total mass we have considered m1 plus m2 plus mn is equal to capital M. So this will be capital M, this will take in left hand side, so M RCM is equal to M1 R1 plus M2 R2 plus Mn Rn. So see it, this is the for center of mass. Differentiating both sides with respect to t, time t, what happened? D by dt mRCM is equal to what? D by dt of total m1 r1 plus m2 r2 plus mn rn. M is constant, that time what happened? M1 is constant and distributed differentiation here. M1 dr1 upon dt, M2 dr2 upon dt, like that mn drn upon dt. dr upon dt of position vector of center mass, so that will be the velocity of center of mass is equal to what? m1 dr upon dt position vector differentiation, so that will be the velocity of mass m1. Same way this will be the velocity of mass m2, this will be the velocity of mass mn. Here we can see this is the total linear momentum of individual mass, summation of, so summation of momentum of all particles, momentum, linear momentum of all particle is equal to linear momentum of center of mass, where total mass is concentrated. So one result we have found it, the total linear momentum of system is equal to product of total mass into velocity of center of mass. So from this we can say the total linear momentum of system is equal to product of total mass to velocity of center of mass of of the system. The very important thing is there. In translatory motion, what we can do? Total, if you want to find the total linear momentum, a summation of linear momentum, total linear momentum of system, that can be directly, we can find the product of total mass and velocity of center of mass. And from here, m, we have taken this hand side, the velocity of center of mass. The very important result is also velocity of center of mass, VCM, is equal to m1 v1 plus m2 v2, same way mn vn divided by total mass, divided by total mass. Total mass mean capital M. So this can be written in the form of also the velocity of center of mass is sigma mi vi I1 to n divided by total mass sigma mi. So this is the formula for velocity of center of mass. The velocity of center of mass, if you want to find of a system, the summation of product of mass into individual velocity divided by total mass. So by this formula we can find the velocity of center of mass. So remember, VCM is equal to m1 v1, m2 v2, mn vn divided by total mass m1 plus m2 plus mn, that is m. See, for acceleration of center of mass, so same thing will be there. What we have found it, we have seen that total momentum, linear momentum is equal to what? Total linear momentum is equal to what? Product of mass into velocity of center of mass. This we have found it. So differentiate it with respect to t. Differentiating with respect to t, time t. What happen? Same way, d by dt of mvcm is equal to what? D by dt of m1 v1 d by dt of m2 v2 d by dt of m2 vn, m we have taken out, derivative of velocity of center of mass with respect to time, so that is acceleration of center of mass. So here we can see m1 dv1 upon ddt, m2 dv2 upon dt, same way mn dvn upon dt. Here we can see here m1 a1 plus m2 a2 plus mn a. Here one thing also we can say, force applied, m1 a1 mean force upon mass m1, force upon mass m2, force upon this also we can write summation of all forces on system is equal to the here total sum of all forces on system is equal to total sum of all forces on system is equal to product of total mass and total mass and acceleration of center of mass. This is very important thing. If any system, many forces are acting, if you want to find the sum of all forces, you can directly find the total mass multiplied by acceleration of center of mass. So that's why what happened, we are considering for translatory motion center of mass, because if you want to find the individual, you can the total force, if you want to find the total force can be obtained by mass into acceleration of center of mass. So this total mass when we concentrated at a point, that is center of mass, so this will give the total effect of individual forces. So that's why we are considering center of mass for rigid body. Also we are taking our system of many masses. So from here also we can see acceleration of center of mass. So from here we can see we have taken this side, to m1a1 plus m2a2 plus mnan divided by, this is center of mass, acceleration of center of mass, total mass m. This also can be written as ACM is equal to sigma form. Also we can write here sigma mi ai, I is equal to 1 to n divided by sigma mi, I is equal to 1 to m total mass. This is the formula for acceleration of center of mass. By this method, if you want to find the acceleration of center of mass, we can find the acceleration of center of mass by total m1a1 m2a2 total forces, individual forces, divided by total mass of the object. We are going to take a 2 kg mass having velocity 3 meter per second and 3 kg mass having velocity 4 meter per second. They have formed a system. Find the velocity of center of mass of this system. What we know? Velocity of center of mass is equal to m1 v1 plus m2 v2. Only two masses, to m1 v1 plus m2 v2 upon total mass m1 plus m2. So here what they have given, mass m1 is 2 kg and their velocity, both are along x-axis, positive direction of x-axis. So we have not write the direction, we not consider direction, only we will say plus 3 meter per second. Mass m2 that has 3 kg and velocity they have given, both are in positive direction of x-axis. That's why we have not taken unit vector ij, that I have not taken. m1 2, velocity is 3, m2 3, velocity 4 upon total mass 2 plus 3, 6, 12. So this will be also along positive direction of x-axis. The velocity of center of mass of this system will be 3.6 meter per second along positive direction of x-axis. See, one question is there. A particle of mass m kg having acceleration 3 meter per second square along positive x-axis and another particle of mass 2 kg having acceleration 4 meter per second square along positive y-axis direction. Find the acceleration of center of mass of this system. तो center of mass का acceleration क्या होगा? तो here we can see what they have given. First mass m1 is m kg and its acceleration a1 is 3 meter per second along positive direction. So we can write it as 3 I cap. Unit vector along x-axis I cap. M2 what they have given 2m kg and its acceleration is positive y-axis, the mean along j cap. So what will be the center of mass? So center of mass formula is what? m1a1 plus m2a2 divided by total mass m1 plus m2. So this is m 3i cap, m2 2m 4j cap divided by m1 plus m2, m plus 2m. Here what happened? M you have taken common, 3i plus 8j divided by 3m. So this will be the 3i plus 8j divided by 3. If you want to find the magnitude will be under root 3 square plus 8 square upon 3. And direction that will be from horizontal tan inverse directed tan inverse 8 upon 3 from x axis. So this will be the acceleration of center of mass.